before we start the official program, I'm going to introduce to you our profile, the Geosightsx company. So I'll be sharing my screen. Just a moment. Are you all able to see the screen? All right, so we are Geosightsx Enterprise Limited, and our offices are in Dodoma, a place called Nkuhungu. So our address is Geosightsx Enterprise Nkuhungu, plot 8. So our mission is that we intend to revolutionize the way industries leverage geospatial data, and also empowering clients with precise, actionable geospatial insights. And our vision is becoming a key player in geospatial community, as well as offering expertise for industry transformation. Our core values: first, we have innovation, integrity, we have sustainability, and excellence, together with collaboration. So all these sum up to our core values. We apply innovation in everything we do. So any work we get from our clients, we do it with considering all these number of factors. Another thing is services that we provide. So we have GIS consulting and analysis. We have real estate GIS solution. We have agricultural GIS solution. There's urban planning and development. We have remote sensing and satellite imagery. And the last one is training and capacity building. So we are open for any of these services to provide to you. We have experts, we have the tools. So all the services are provided with high amount of commitment. Yes. And the industries that we serve, first is the real estate. We also serve the agricultural sector, urban planning, environmental management, transportation, utilities, and mining. So we apply different technologies. For example, the drone industry that can also apply in all these industries mentioned above. So we intend to welcome you guys officially to our company for any kind of services that you intend to get. And yeah, so before we go to my other colleague presenting, Engineer Mompamba, I also have a very short presentation here. Just quickly. Yes, so here it's all about how we apply drone technology in the water and quality monitoring. So our topic says harnessing drone technology for water quality monitoring. And the heading is innovative solutions for sustainable water management, presented by myself. Yes, so here, before introducing the solution, I wanted to show you the challenges. So we have accessibility of remote water bodies. So sometimes accessing the water bodies which are in remote areas is hard. So having drone technology is going to be a solution there. Another thing is high cost for traditional survey methods. And another challenge is time consuming. data collection processes. So the solution here comes in as drone offers cost-effective method, time-efficient, and high-precision alternative. And this also depends with the kind of drones you use, the sensors applied, etc. And applications of drone in water quality monitoring involves aerial imaging, whereas it helps to detect algal blooms and pollutants. So by aerial imagery, after collecting the data, you can have some analysis that can help you to detect this pollutant or the algae. Another thing is sensor integration, whereby real-time data collection on parameters like pH, temperature, and turbidity are also made possible. And also sampling assistance, whereby there's a technology of automated water sampling in hard-to-reach areas. Another thing is application of drones in bathymetry survey, where capabilities is that LiDAR and sonar integration. This gives high resolution underwater topography mapping. So by using LiDAR sensors that can be integrated in the drone, as a sensor, it can assist us to get high accurate or high resolution topography map. And also we can be able to make to do shallow water efficiency, whereby drones they operate in areas that are not accessible to travel, maybe via boats. And this means it's going to use the technology like echo sounders and the devices that go underwater. Also speed and precision, whereby deploying a drone in your site, it helps you to increase the speed of the work, but also precision. For example, if you use a Mavic 3 enterprise drone that has RTK embedded in it, it can assist you to get high accurate data, but also in a short time. Also, the use cases include reservoir volume estimation, sediment management, and dredging planning, together with flood modeling and risk assessment. So all this can be made possible and accurately by the use of right tools and the right equipment. So advantages of drone technology, the first, efficiency, whereby as we say efficiency, it means reducing manpower that is being used and also reducing the time that is being used there. And another thing is cost saving. So when you use drone technology, it reduces even the number of days you're going to be on site and reduces the manpower that you're going to use in site. So automatically it's going to reduce the cost that you would have used if you opted for other methods. Another thing is data quality, whereas high resolution imagery and precise measurements are being provided to you by the use of drones. Another thing is environmental impact, so it minimally disturbs any aquatic ecosystem or anything that is on surface. And the last one is flexibility, so adaptable for various terrains and water conditions. Drones are able to reach in areas where we can't reach. So this brings the actual meaning of remote sensing, that you're able to get data from areas that are unable for you to reach. So my colleague Engineer Mwampamba is going to present for us more about remote sensing, and you will get to see what exactly I mean. Although we also have things like satellite images, etc. So how it works, the drones, it's like first by planning. When you want to conduct your project in any area, you have to plan. So it says define survey areas and objectives. So after you know where you want to fly your drone, let's say the area of interest, you're going now to use the software to create a flight plan according to the area of interest. That's then you're going to have specified your survey area. Another thing is execution, whereby now after flight planning, you're going to execute now your drone by deploying it together with the right sensors and the right cameras that you're going to need. Or if it's underwater, that means it's going to be the sonar. Another thing is data analysis, whereas after coming from site, you're going to have a memory card from your drone that is going to have the data. You're going to process it. You'll do pre-processing that involves things like mosaicing until now you come to do the data processing, which now gives you data visualization and interpretation. So here, the end part is now reporting, whereby you generate actionable insights for decision making. That is the last section, whereby now you are coming up with a solution to give your client. So we welcome you very much at Geosightsx. We also provide these kind of services, and right now I'd like to welcome now Engineer Mwampamba so that he can bring you through remote sensing. Welcome, Engineer Mwampamba. Oh, I think you haven't muted. Please unmute. We can't hear you.
Yeah, good evening to you all.
Good evening.
Thank you. Let me share my screen. Can you see my screen?
Yes, we can see it.
Okay, thank you. My role this evening is just to give into your site the power of remote sensing. We are going to know what is remote sensing. So I'm sure that each one who is here is going to understand. Brenda has brought us some things, some applications of drone. So I'm going to take you through the power of remote sensing. You should know and understand the definition, so you know where can you apply this technology. When we say remote sensing, we simply means acquisition of information about an object or phenomenon without making physical contact with it. So I'll give you an example, which is in our really daily life. For example, you are taking a photo on something, be it an object or phenomenon. That is remote sensing, because it's like you are acquiring information about that object without getting into physical contact with it. But now, when we say remote sensing, this term is applied especially when now you are acquiring information about Earth or any other planet. For example, you are taking a picture, or you are taking, yes, you're taking a picture on Earth using drone or using any other device. That now is called remote sensing, because taking a picture, this means that you are not getting into physical contact with the Earth. So we can visualize this picture, which shows here above the Earth we have satellites, but also we have drones which we can fly them. And then you see that these satellites used to take pictures, used to take images over the Earth. But also drones, when they are being flied, they can take pictures. So under here you can see this image. This is the product, of satellites, but also drones which have been flown. Now, this is remote sensing, because you are taking information on the Earth. Information can be maybe water extent, how much water is available on Earth, maybe vegetation cover, which is available, maybe for animals or whatever kind of uses. So you take information on the Earth, and the output is this image down here. And then after you getting this image from maybe satellites or drones which have been flown, then you can classify them. You can classify based on divisions, maybe forests, water bodies, and whatever kind of of classes available on Earth. But also you can do analysis of this image. You can analyze these images that has been produced by satellites and drones. Now this analysis is done by using softwares. Yeah, we use softwares, and softwares, there are so many available for doing analysis of remotely sensed data. One of them maybe you came across by hearing, or maybe anyhow, we call them Arcgis, QGIS, or sometimes Google Earth Engine. These are softwares which you can use them to do any analysis or classification of these images that has been captured by these devices which take images over the Earth, and that is remote sensing. When we speak of career, we are speaking now of an individual who is now sitting on the desk and do this classification and the analysis of the images. So as I have said, software is there. Are those available that we download them and we have them in our computer, like QGIS, Arcgis, Google Earth Engine, and whatever. So now satellite remote sensing, for me, as I've said, Brenda took us through, drone remote sensing. That means that data being taken by drones. But now you can also access satellite images, satellite data, which are remotely sensed data. Now it is increasingly being used as the complementary source of information to in situ monitoring networks, and in many cases is the only feasible source. So this sentence means that satellite remotely sensed data has been now far better than the in situ monitoring kind of data. When I say in situ monitoring, is that maybe you are going physically at a place and taking some data. Maybe you want to measure how much that this forest cover in terms of area, maybe square kilometers. This now is in situ data. You're going there physically. But now this event or this function can be performed using remote sensing, the data which has been sensed by satellite. So this is the power of remote sensing. But also, according to some literatures mentioned here, you can find, this is just in-text citation, but I've attached the full references indicating this, how remote sensing is powerful. This sentence says that satellite-based sensors are now capable of making direct and indirect measurement of nearly all components of a hydrological cycle. We all know what is a hydrological cycle. It's just the cycle of water on Earth. And you can see these are the components. These are the components, and nearly all these components can be accessed through satellite remote sensing. But also, maybe to go in detail, we can have precipitation through remote sensing. We can access these data. We can access data of evaporation. Maybe we need to know how much water is lost through evaporation in our water bodies or even in our fields. We want to know evaporation that is happening in the soil. How much water are we losing? So we can know through remote sensing. But also lake and river levels and the extents. And this case now is going to be explained in details by Raphael. We are going to see. When I say of extent, I'm speaking of surface area. Surface area of water bodies is kept on changing because of climatic variations. But also surface water, we can know how much amount is available using remote sensing. Soil moisture, as I've said, snow, but also total water storage. This is just the components of hydrological cycle, as I've said in the previous slide. So these sensors are therefore capable of providing critical information in support of managing water and monitoring the evolution of hazards and their impact. This is according to Vanjik and Leswolo 2011. So sensing, you can use it anywhere. You can use it anyhow, as I've explained. But today, as I've said, we're going to just go in detail on lakes, levels, and extents. And this is going to be presented by Raphael. Thank you, Mr. Raphael. I would like to invite you for the next part. Or
Yes,
maybe
thank you very
before
much.
we invite Raphael. Yes?
Okay,
Is
please
there,
proceed.
is there any concern from anyone? Maybe somewhere is not understood. I'm here to clarify. So thank you, Mr. Raphael. You're welcome for the next part.
Everyone to thank you, Engineer Mompamba. Please, anyone feel free to type your questions in the chat so that in the end of the session, you can be answered by Mr. Mompamba. So next is Mr. Rafael Musa. Welcome very much for your presentation and demonstration. Yes, we can see your screen.
Yeah. We just visit Geosightsx. Under the product, you will visit Geosightsx. And here I'll be giving you just a high-level overview of the what is Geosightsx. So we'll be directly to the landing page. So Geosightsx help you to discover similar landscapes, not only lakes, but you can also identify the area with bare land within your region of interest. You can identify the area with wetland within the area of interest.
You can identify bare land area within the area of interest just by one click, one training sample, using this procedure which I'm going to show you now. And this product is developed by us, Geosightsx Enterprise. So we have Geosightsx, which helps you to discover the similar landscape. So the key feature, what are the key features of Geosightsx which makes it very useful for you and different applications? It has interactive map interface. You can draw, you can do everything, and we have used the Earth Google Earth Engine as an API. So it has also environmental layer selection. You can opt to select more than one layer. We have almost 12 layers which do not need you to compute them, but you can select them and use them for your analysis. It has also dynamic similarity analysis. A dynamic similarity analysis helps you to identify the similarity dynamically. You can do analysis even more than one feature. So it has a threshold adjustment and downloadable results. And who is it for? It is for environmental researcher, conservation scientist, agriculture expert, and general GIS lovers. So once you get here to the landing page, you just click see demo. And actually the demo is the real site now where you're going to visit these two. So once you click, the tool will load and display to you there. So now this is user interface. You can search for any location in link, and it will be easier for you to do analysis. So the first step is the tool is user friendly and interactive. So it gives you, the first step is to draw the area of interest or sensing extent. So first you need to identify where you need to do your analysis. So we'll take you more together to Lake Sulungu, which is our area of interest for today. So it will zoom direct to the lake, and you'll have just to define the area of interest where the lake is all included. You can use this tool to pan. Like here, I have now the lake at the center. Now I'm using this drawing tool to draw the bounding box, which will be now the area of interest. As you can see. After that, I'm going to click this button that will allow now the software to define the area of interest. Now the area of interest has been defined. Then the next step, the software will tell you, is select the environmental factor to analyze. So we know water and vegetation have the inversely proportional. The place where there is a lot of water, the place where there is surface water exposed, we are not expecting to see vegetation on top of the water. So for this time I can use only vegetation health factor, and I can opt to use water coverage factor to combine these two factors so that the area should match the same characteristics of vegetation health and water coverage indicator, the area I want to identify. And I will choose the year. This is very important. You want to do the change detection from the year 2020. So after that, now I will hit the button apply the selection. Once you apply the selection, you will see the reagent now is loading, and it will tell you the vegetation health factor will be ranging from white to green, and the water coverage indicator will be ranging from white to blue. So the layer will be loading here. Okay, here we go. Now we have the layer already loaded. So after that, we are going to define now the sample region. Only one training sample is needed to make this software be able to understand what you need. So if you want a bare land, you will pick a sample for bare land. But for our case, we are looking for water extent. So we will just select the area where we see this is water. Just only training sample, only one. You can use more, but even one is more effective. Just use any drawing tools here. You can draw a cycle, or you can use this polygon to draw a polygon. You can draw a polygon. For this time, I don't need this. I'll delete. After that, now we'll be able now to submit sample details. After submitting, the software will take some few seconds to process the image and to give you the water extent level. Now the water extent level will be loading for that period for 2020. You see now the lake Surung has been carefully delineated. I hope everyone now can see this. Switch off this training sample and see now this for the extent of Lake Surung for the year 2020. So, if you see you have some parts which are not captured and you need maybe to adjust more similarity so that you can capture more similar area to this lake, now we have this dynamic similarity adjust. So you can adjust similarity maybe to 0.2 and recalculate again. See? So you can just resubmit the sample again and it will come with the layer which has good similarity chart. So for this now, this is reasonable. Then you can be able to download this result. Hit download result. The link to download will appear here. You just click the link and it will direct you to download. So I'm hoping there is no question, and I'll be proceeding to the next procedure. Okay, Engineer Mankupil, welcome. Oscar, we cannot hear you. You can unmute your mic. Oscar Mankupil, we cannot hear you. Is it happening only on me?
No, it's for all of us. I think since he cannot yet unmute his mic, maybe he can type in the chat.
Yes. Oscar, if you cannot speak or you have problems with your audio systems, you can just type in the chat area and Miss Brett will be there to read and copy the question. However, we have your contact information. If your question will not be attended here, we will just reply you with a good email. Okay, see now we can speak.
Okay. Good evening, everybody.
Yeah.
Okay, thanks. I have one question to the last presenter. Yeah, I'm asking. You have shown that lake. So is that your lake around Tanzania? You have all captured the information you have, or just that was a sample for one of the lake?
Yes. Okay. The app is dynamic and it has a dynamic interface. So it's not only that lake. You can do good lake in Tanzania. You can do the same analysis I'm teaching here to Lake Ayers, to Lake any lake, even in Kenya, in Uganda, all over the world, where veterinary data is captured.
Okay. So to the first presenter who told us you may take some measurement like what we call pH of the water and the others. So how is that related to your information you've already captured? You have all map around you have all map of the rivers of the lake. So how can I do measurement of pH to the data you have already collected you?
Yes. See, to that area, I will just providing you with a high level also help you a lot. But to give you just a high level, the remote sensing image consists of several bands, and each band is having a capability to obtain specific information about an object it gets into contact. So if we have near infrared, we have the red band, we have the blue band. So all of those bands, when they get into contact with the water, not only those, we have also shortwave infrared. So when they get into contact with water, they can be processed and analyzed now to provide the information about the pH, the turbidity, the chlorophyll, and other water quality parameters. Perhaps Engineer Mampamba can add a single statement over mine, because I know him. He's now focused a lot on water quality monitoring. So Engineer Mampamba, you can just add a single statement so that we continue with our next procedure.
Okay, thank you for the nice question, Dr. Oscar. Maybe allow me to share my screen so I can show you just one of the software, as I said, and then we can now understand how can somebody calculate parameters.
Okay, continue.
Yeah. Can you see my screen?
Yes, I can see.
Yeah, just give you an example of this one. This is just a software. As we have said, remotely sensed data can be processed by softwares. You download the softwares in your device, and then you can process anyhow. And when we say remotely sensed data here, we just mean image, which can be taken by drone or can be taken by satellites. Now, satellite images are available. For example, this is one of the software. I can search here. For example, you need to know names of satellites available. For example, this one is called Sentinel. It's called Sentinel. You can see here.
Can you turn on your screen?
I'm not
Yes.
able to see the screen you are sharing, Mampamba. Maybe Brenda, can you confirm if this is only happening to me?
No, he's not sharing it.
Okay.
You can share.
I did some mistake. Sorry.
Okay.
Thank you.
There, now you can see.
Yes, now we can see the screen. Thank you.
Okay. Dr. Oscar, can you see?
Yeah, I can see the screen. Google Earth Engine.
Yeah, now this is one of the softwares. I said you can download several softwares and can be used to process these images, these satellite images or drone images, as has been presented by Madam Brenda. So you need to know the name of the satellite. For example, one of the satellite is called Sentinel. But here you can also search for another satellite which is called Landsat. Landsat. You see? It's called Landsat. These are different satellites which were launched by some people in the years back. So for me, for example, I'll go for Sentinel. I'll show you something here, just to appreciate what I'm saying. Now, when you come here, you will find different options here. You can choose. For example, when you go to this one, something like this will pop up, and then you have this image which was collected by this satellite. You can see here the bands. You come here to the bands. So every image that is being taken by satellite, it has got bands, like what you see here. The bands, we have band 1, band 2, band 3, band 4, band 5. As you can see, all these are bands that are within that image that is being taken by the satellite. So now to calculate maybe pH, there are formulas which maybe I'll give you an example of one of the parameter. Maybe you want to calculate pH. There are formulas which uses these bends. Maybe if you take bend 5 minus bend 4, then you are getting a certain parameter. So this now involves literature. You need to go through literature to know if I want to get which parameter, then I use which bends in my satellite image. Are you there?
Yes, I get you.
Yeah, so for example, you want to calculate maybe vegetation index, normalized vegetation index. You want to know vegetation cover of a certain area. You see, maybe, yes, you want to know vegetation cover. There are formulas which includes band 3, if I've not forgotten, band 5 and band 8. No, band 3 and band 8. Yeah, if I've not mistaken. So if you take the normalized difference ratios of these bands, then you are there. It gives you an image which shows only vegetation cover in that particular area.
Okay,
So
thanks.
this is how you go about it. And all this computation, you come back and do them in the same I mean software. You can see here.
Yes. Sorry, Engineer Montamba, could you try to make it as brief as possible because we are running out of time?
Yeah, of course.
Thank you.
I'm done. So you come back to the software, then you write those formulas, and then this is how now you can achieve.
Process now. Specifically, this object which we have used as you are going to add the layer. So the first downloaded layer is this one for 2020. The second layer will be for 2024. Now I will have the layer for 2024. This one I will add it. You can see now the difference, even if without processing, you can see the differences. I know you can see it. So the first option will be to convert this raster to polygons. Convert this raster to polygons. So just search conversion tools and raster to polygons. Go as fast as possible since we have very few time remaining. So the first input raster will be 2024 tip. Someone mute.
Mr. Osha and Engineer Montamba, will you please mute your mic?
Then I will need.
Yale yote mimi amebaki kusafiri ya kazi. Sasa hiyo ndio sio. Unakuwa sana au sasa utakapokuja mtu anatuma kwa share dawa. Pia kwangu ile pembeni. Sisi wewe
noted by yellow, and the operating area. Do the also do what is this to get to red, red. Now this was all. This was
depending on the model. But also there are type of drones that are called fixed wings and another one which is called hybrid drones. So all these have different range in terms of meters or kilometers. So for multi-rotor drones, mostly it has about 2,000 up to 10,000 meters. And this also depends with the model and condition. So for example, models like maybe a DJI Mavic 3E, it's those type of drones I'm talking about, or maybe a drone like the DJI Arcgis T40, those ones. So when I talk also about fixed wing, I mean the drones that have some kind of resemblance as an airplane, a normal human-bodied airplane, which this one now goes from 50,000 to about 10,000 meters, or it can go further depending also on the model. For example, in this kind of category, there are drones that are designed as end user commercial drones. So these go even up to 2,000 kilometers. Depends now with the function or how it was designed. And lastly, we have hybrid drones, whereby hybrid drone is a drone that is combined ability to take off vertically but also goes horizontally. So this makes a drone able to take off vertically. This now goes from 10,000 to 30,000 meters. So having a hybrid drone, the benefit is just that you can land in any confined space because it's a fixed wing, but it has the ability to take off vertically. When I say vertically, it means it can take off just like a multi-rotor drone, but when it is on air, it can convert the flying mode to horizontal, which now goes like a fixed wing. So this one doesn't have a very long range compared to the fixed wings, but they at least reach about 30,000 meters. So I hope I've answered your questions, but in all the models or the types of drones, all these depend on the payload they're carrying. So if the payload is very heavy, that's going to be taking more time. But also if there are obstructions in the area, maybe like mountains, that also affects. If there is high winds, maybe high temperature, it also reduces the time the battery can sustain. And also the drone technology, the battery technology. For example, if it's a drone that uses lithium polymer or lithium ion, or some other drones are designed to use things like petrol, etc. So all that is also depending on, it's a dependent factor that can lead to the range or how long the drone can fly. So thank you for your question. Also welcome others. If you have any questions, please raise your hand. Hello?
Yes, Brenda, I can hear you. Maybe I can add something about to make Oscar be able maybe to understand. So he has asked how long in meters do drone go in case of taking water sample or image in case of trials surely a large water scale remote area. So actually now based on what you need, resolution we need, the ground sample distance. So all the configuration based on output requirement, it will decide the amount of time which will be required now to take the sample or to take the full picture of the large scale area you're talking about. So thank you, Brenda. Over to you.
Yes, thank you very much, Joseph Raphael, for adding that. I appreciate very much for everyone who took their time to join us in this webinar. It's such with great honor would like to appreciate. And for those who will have questions and maybe would like to draft them to us, you can share them via email. Can Mr. Raphael, please, can you share the company email?
Yes.
Yes, so anyone with questions and would like to send them later on, you're welcome. You can send them and they shall be replied to you via email. So thank you all for joining. Have a wonderful time. Good evening. Right. So the email has been shared to the chat. For those interested, please use that email for any communication. If you would like to have consultancy with us or any kind of work you want to collaborate, you're all welcome. Have a great evening.
Thank you, everyone. This marks the end of our webinar. Have a nice and wonderful holidays. Now you can
Thank you. Okay, thank you.
Engineer Mampamba and Brenda.
Yes, congratulations everyone. You did great. We went on time.
Yeah,
That's wonderful.
and we are 4 minutes back, so we have not spent. Someone wants to join this time.
Oh, that's happening. Late comer. Aliyepitiliza.
Yeah, he's the late comer. Guys, I would like to extend first my thanks to you. Thank you, Brenda, very much. Thank you very much, Engineer Mambamba.
Thank
For
you.
a very short time, we have known each other and we have been supportive to each other. I appreciate your presence too much. Today, you have done a very wonderful job, and I didn't know if you will share this kind of nondo here. So thank you very much for your good presentation, and over to you, Brenda. I appreciate so much. You have been good timekeeper. You have done very wise job, very nice. And actually, I hope the meeting was not boring. I hope the meeting was good. So, as I am expecting to hear some of good feedback, I would like first to give you my acknowledgement. You guys have done a very wonderful job, very amazing job. Your presentation were extremely attractive and I like them. Actually, thank you, Brenda and
Thank you so much, my brother.
Thank you very much, Mr. Raphael. We
Maybe
appreciate also for the opportunity.
thank you so much. I would like to advise maybe maybe the other time we are doing, we should record and then attach the webinar, the recorded